Okay, all of that was Chem 20 review. Now we jump into Chem 30. This is actual Chem 30 now. Here we go. We're going to talk about organic compounds. Those are just carbon compounds. We're going to talk about some exceptions. They contain carbon, but they're inorganic. We'll talk about that in a second. And we're going to define these things called isomers. Same formulas, different structures. Okay, organic chemistry. Well, in this unit we're going to talk about compounds of carbon, or carbon chemistry. So everything we talk about will be a compound based out of carbon. There are a few exceptions. The first exception, these ones that are not organic or inorganic, is the oxides. So if you have a carbon with an oxygen, like carbon monoxide, carbon dioxide, even though there's a carbon, it's considered inorganic. Now we can have carbonates, like we could have calcium carbonate. Now there's our C, carbon. You'd think it was organic, because almost every compound that contains a C is organic, but this is an exception. This is inorganic. Okay, calcium carbonate. So you can see that's an element in antacids like Tums or Rolaids. Okay, I said an element. I meant a component. Okay, that's a compound in an antacid. Okay, there's these things called cyanides. Notice there's a C there, but it's called sodium cyanide. When you have the CN combination, cyanide, it is also inorganic. We use cyanides to extract gold from their ores or from their metals. So we get gold by pouring cyanide over these rocks, and it's way more complicated than that, but there you go. And also carbide ions, calcium carbide. So if you have a name that ends with carbide, calcium carbide, it's inorganic. You will have to memorize these: oxides, carbonates, cyanides, carbides. Those four are inorganic. Probably a question on the diploma exam regarding those. Okay, there are many ways to represent organic compounds. All right, so for example, here's an organic compound. Notice it contains 1, 2, 3, 4, 5 carbons, and all these white ones are H's. Now, back to this sentence here. This said there's a number of ways of drawing organic compounds. Each has its strengths and its weaknesses. So let's take a look at what I mean by that. So there's a molecular formula. It just lists all the atoms like this: C5H12. This is 1, 2, 3, 4, 5 carbons, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 H's. This C5H12 is one way to represent that molecule. But we don't have to write it that way. We could write it this way. We could use an expanded molecular formula. And this is what this looks like. So see if you can follow this. CH3, there's my CH3. And then it's connected to C with an H, which is right here, CH. And then CH has a branch coming off of it. 1, 2, 3, CH3. Now when there's a bracket, that tells me it's in a branch. And then I've connected to CH2, CH2, connected to CH3. There it is. Okay, so look at the difference. There's that, or there's this. Now actually I like this one for simplicity, but I like this because it shows me what it kind of looks like. Then there's these things called structural diagrams, which look like this. Now you can see it's the same thing. CH3, 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 and then C with an H. That would be this part. And then there's the branch, and then CH2, CH3. Okay, we'll keep going here. Now there's condensed structural diagrams. Now take a look at what this picture looks like. Now there it is. Now I've flipped it from left to right. I've flipped it horizontally. and the branch is now facing down. So I'm going to flip this, if you just watch this carefully, I'm going to flip it both horizontally and vertically so that you can see it doesn't matter which way we rotate these things, we still have exactly the same picture here. We'll talk about that later on, how that works. But so you can see CH3, CH3 connected to CH. There's my CH. There's my branch, CH3, CH3, and then CH2, CH3. Okay? Alright, and then I have line diagrams, which look like this. So here's my 4-carbon chain, and here's my branch. There's my 4 carbons, there's my branch. Alright, now we're going to deal with, in this class, line diagrams, condensed structural diagrams, and structural diagrams. So those three we really focus on. You have to learn how to draw all of those varieties. And there's these things called isomers. Here's what an isomer is. It's the same molecular formula, but a different molecular structure. In other words, same formula, different shape. Okay? For example, C4H10 has 2 isomers. Watch this. There's this one. 1, 2, 3, 4. 4 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C4H10. Now I can draw that another way. Look at this. 1, 2, 3, 4. 4 carbons. And then I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are the same formula, C4H10, but they have different structures. They look different. That's what an isomer is. Now, those are the only isomers for C4H10. Now, as the carbon atoms increase, the number of isomers increases. So the more carbons we have, like C5, C6, C7, C1000, the more isomers you have. And because of that, we don't use molecular formulas like this very often. We'd rather draw them, use a structural formula, because C5H12 might have 3 different diagrams, 3 isomers, but C100 is going to have like thousands upon thousands upon thousands of different isomers. And so this C100H2O2 doesn't really tell us much. If we drew them all, we would know more about them, at least by their structure. Okay, so your first assignment is going to be get out the modeling kits and create 3 isomers for C5H12. That is Chemistry 30, assignment number 1. How easy is that?